Hi, welcome to Microbiology Mentor. We are here to discuss yet another important topic, biomedical waste management. So let's see what are the learning objectives. The learner after this session must explain what is biomedical waste and its hazard, must classify the biomedical waste, must explain the importance of biomedical waste and its management, and must discuss the biomedical waste management workflow. So in order to complete this objectives, I have compiled my lecture under following headings: introduction, where I will be discussing about the definitions of biomedical waste, various waste types, as well as burden and concern of biomedical waste. Again, biomedical waste rules, various categories of biomedical waste, the steps of waste management, as well as segregation of waste, finally waste treatment and disposal. So let's define biomedical waste. So biomedical waste is defined as any waste which is generated during diagnosis, treatment or immunization of human being or animals or research activities or in production of testing of biological sample. Remember, it also includes similar kind of waste generated at household level due to healthcare offered at household level. So the question comes in mind, why we should be concerned? Why to waste time on waste? So we should be concerned because this biomedical waste is generated in our country in approximately 484 ton per day from approximately 1,68,000 healthcare facilities. So this is huge in number, and the worst part of it is that almost 37 ton per day of these biomedical waste are left untreated, which is a hazardous, and it causes serious concern not only to the hospital healthcare personnel who are handling or treating or disposing these biomedical waste, but also to the general population. So they are hazardous in nature. So we should be concerned to minimize the risk to human and environmental health. Therefore, safe handling method of biomedical waste, its disposal and its treatment must be instituted. So before actually going into the detail of managing biomedical waste, let's see various types of waste. So you must have learned a type called infectious waste. What is that? Infectious waste include all those medical waste which have potential to transmit viral, bacterial, fungal or parasitic diseases. It includes both human and animal infectious waste. So what is a hazardous waste? Any waste with a potential to pose a threat to human health and its life and life is called hazardous waste. So a hazardous waste is a broader term which includes infectious and non-infectious waste both. So then there are pathological waste. Pathological waste are human tissues, organs or fluid body part and contaminated animal carcasses. Then there are sharp waste. Sharp waste are syringes, needles, disposable scalpels and blades. Then there are chemical waste, which is actually the solvent used for laboratory preparation. It can be disinfectant also, and heavy metals like mercury, which is often used in thermometers, as well as chemicals like lithium, which can be used in batteries. Then there are pharmaceuticals waste, which include expired, unused and contaminated drugs and vaccines. Then there are another types of waste, I will say, is genotoxic waste, which is highly hazardous, mutagenic, teratogenic or carcinogenic, such as cytotoxic drugs and their metabolites. Then there are radioactive waste. Radioactive waste are the waste that are generated during the diagnosis of any radiological procedure or some therapeutic radiotherapeutic options. Then there are non-hazardous and general waste. So this is another type of waste which do not pose any particular biological, chemical or radioactive or physical hazard to either human or animal. So let's see the hospital waste composition. So it is important to note that a majority, almost 80% of the hospital waste is a general waste which is harmless and non-hazardous. The remaining waste, which comprises almost 20%, are infectious and pathological waste, which makes around 15%, whereas chemical and pharmaceutical waste, which makes 3%, and 1% of sharp waste, which is also another important component of infectious waste. So you can see that the majority of the waste is general waste, but yet this general waste, although non-infectious, but when it is mixed with a small portion, that is 20% of infectious waste, entire component, that is 100% of waste, will become infectious. So it is important to segregate waste. Let's see the potential hazard of healthcare waste, which include the infection to the patient, the infection to the and injury to the waste handlers like the healthcare personnel, where it causes needle stick injuries which may lead to HIV or hepatitis B infection. Then infection to the rat pickers, it is also one of the big major problem. Then the hazard which arise because of healthcare waste is also of water pollution as well as air pollution. At the same time, there are hazard to the animals who and the rodents or other insects, where they can accidentally eat those waste, get infected, and finally lead to the infection of human being. Then hazard, of course, of these biomedical waste is to the healthcare provider also. So now let's see what are the sources of these healthcare waste. So the sources includes general hospital, government hospital, private hospital, nursing homes, physician clinic, dental clinic, dispensaries, mortuaries, blood banks and collection centers, animal houses, as well as other diagnostic centers or any other research centers. So who are at risk of this biomedical waste hazard? So the primary risk primarily at risk are the generator. The generator includes those person that generates these biomedical waste, includes the hospitals or healthcare workers. Then the handlers who actually uh, segregates or handle these biomedical waste or treats or dispose these waste. Then finally it is also the exposed group. The exposed group even includes the common public or the patients or the attendants of hospitals. So biomedical, let's see what were the biomedical rules. So as these biomedical waste were mishandled and not properly treated, so taking this cognizance, the Ministry of Environment and Forest notified the biomedical rule of managing and handling these biomedical waste. So it was Ministry of Environment and Forest that formulated these rule in year 1998 in the month of July. So these biomedical waste management rules thereafter undergone timely revision to meet the prevailing needs, and till date there are at least 4 amendments in this rule in The first amendment was in year 2000, whereas second was in 2003, 2011, and finally the recent one amendments include the amendments which was made in 2016. So let's see what are the biomedical waste rules. Previously, according to the biomedical waste rule, there were 10 different categories of waste segregation. So what were the 10 different categories? These 10 different categories were later although reduced to 8. Let's see what were the 8 categories. So these were category 1 to 8. You can see here this included human anatomical, animal anatomical waste, microbiological waste, sharp waste, discarded medicine in the 5th category, soiled waste, then liquid waste, then incineration, ashes and other chemical waste. So these were different 8 categories of biomedical waste, but this category was actually formulated. Then it was actually difficult to remember and segregate biomedical waste because this categorization was have operational problem. So later it was amended to 4 categories of the biomedical waste based on the color type of waste, that the color coding of the waste based on the color coding, as well as the treatment options. So based on the color and the treatment options, these biomedical waste were clubbed or categorized in 4 categories. So this recent 2016 rules of biomedical waste was a bit beneficial because this new rule increased the coverage of biomedical waste, simplified the categorization, improved segregation, transportation, as well as disposal method to decrease the environmental pollution which arises because of these biomedical waste. So let's see biomedical waste rule 2016 in detail. So according to this rule, as I have already told, that biomedical waste were categorized in different color codes including yellow, red, white, as well as blue color. Based on these color code, they have different treatment options. Okay, so let's see different biomedical waste categories in detail. First, let's start with yellow color. So this yellow color included biomedical waste like human anatomical waste, animal anatomical waste, then soiled waste, expired or discarded medicine, chemical waste, chemical liquid waste, discarded linen, mattresses, bedding contaminated with blood and body fluid, microbiology and biotechnology and other laboratory waste. So these were clubbed under yellow categories, and the treatment option was incineration or plasma pyrolysis or deep burial. So these had an option of permanent disposal, okay, after getting treated. So this category, red category, is one which was formulated with a principle of recycle and reuse. So R is for red, R is for recycle, and R is for reuse. So this include the waste which can be recyclable, like plastic waste like tubing, bottles, intravenous tubes and sets, catheter, urine bags, syringes without needle and fixed needles syringes, as well as gloves. So this category was formulated because this could be reused. So for mnemonic for this is R for red and R for reuse or recycle. So the treatment options included autoclaving, microwaving, hydroclaving, and then it was sent for recycling. So it was sent for recycling. Remember, it is not to be landfill. So it was reused based on the principle of reusing. Then another category was white, category wise. So this included waste which are metallic sharp. So you can see that if you just try to memorize it, if you just invert this W, it will be M. So this will be metallic M and sharp waste. So what is metallic sharp waste? Which include needles, syringes with fixed needle, needles and needle from the needle tip cutter or burner, scalpel, blades or any other contaminated sharp object which may cause puncture and cut, and this included both used, discarded and contaminated metal sharps. So these were under categories, and the treatment, the permanent treatment option included autoclaving and or dry heat sterilization followed by shredding and mutilation and encapsulation. So these waste were in white category. So let's see blue category. So this blue category included glassware. So these are glasswares which are broken or discarded and contaminated glass, including the medicine vial, ampoules, except those of that of cytotoxic waste, and metallic body implants. So you can see the metallic body implants, these are also placed under this blue category. So for mnemonic you can remember that glass, all glass are made by glass blowing. So this is B for blue, and this is glass phase. So this is also treated by disinfection or autoclaving as well as microwaving followed or hydroclaving, and then it is sent for recycling. So this was also made on the concept of reuse as well as recycle, but this color is blue. So because it used glass, the glass waste or the metallic implant, so it can be reused. So let's see the principle of biomedical waste management. So this is the principle of biomedical waste management rule 2016, which was based on the concept that of 3R. So 3R is reduce. So you have to decrease as much as possible the production of biomedical waste, as well as you have to use recycle and reuse it. So you have to make a treatment option that should be recyclable and reusable. So this principle was also aimed to avoid generation of waste or recover as much as waste as possible. At the same time, the waste should be tackled at the beginning rather than tackling at the end. So this was a principle of it of the biomedical waste 2016 with an approach. This approach was designed to keeping in mind the safety of all worker who are handling or generating biomedical waste, the patient for which biomedical waste is generated, at the same time the treatment process which is generating an environment pollution. So it was approached to design keeping in mind the safety of worker, patient and environment. So now let's see the steps in the waste management. So the key steps of the waste management of a biomedical waste include the segregation of waste, which should be done primarily at the point of generation. Then the normal cycle includes the transportation of waste from the generation cycle to the central storage area where the waste is collected and stored shortly till it is being picked up by a common biomedical waste treatment facility where it is finally treated and disposed. But in between, what is this pre-treatment of the waste? So pre-treatment of the waste is again a newer concept which is added in 2016 rules, where all the laboratory liquid waste as well as microbiology waste should be pre-treated after the completion or after the generation of this waste. So any laboratory waste or liquid laboratory waste or microbiology waste should be pre-treated before it is segregated or before it is handed over to the common biomedical waste treatment facilities. So let's see the segregation of waste. There are certain points to remember while segregating the waste. So it should be done prior to the treatment and disposal of the waste, preferably at the point of generation of the waste. Okay, then it safeguards the occupational health care personnel, and the segregation should be preferably done, or it should be done in a covered container. At the same time, uh, this segregation helps in safe handling and transportation of this biomedical waste. Now let's see the various treatment options which we have discussed just now, like incineration, as well as the problem of this incineration, plasma pyrolysis, then autoclaving, microwaving, hydroclaving, and encapsulation and inertisation. So let's see each one, the importance as well as the drawback. So incineration, as it is said that this is burning of organic waste into to a higher temperature of approximately 1200 degrees centigrade, which reduces the organic load, and it converts the organic into non-organic and incombustible, combined with at the same time reduction in volume and the waste and the weight. But there are certain drawbacks or problem that arise because of incineration, which includes: number one, a lot of toxin are produced during these operations, such as dioxins as well as furans, which are toxic gases which produce because of the combination of gases at higher temperature. Then there are, again, during incineration and post combustion cooling, waste component dissociate and recombine to form PIC, that is product of incomplete combustion, which is again potential harmful. Then metals, another problem is that metals are not destroyed but they are dispersed into the environment and they can cause serious health issues. So these were few challenges. Therefore certain group of waste should not be incinerated, like pasteurized gas container, radioactive chemical waste, then halogenated chemical waste, halogenated plastic like PVC waste, and heavy metals like mercury, silver, radiographic waste or broken thermometer. These should not be incinerated. So overcoming this problem, this new technique, plasma pyrolysis, was developed. So this is a state of art technology for safe and disposal of biomedical waste. It is comparatively an environment friendly technology which converts organic waste into commercially useful products. So these convert waste into commercially some useful products. Here also intense heat is generated by plasma, enabling it to dispose biomedical waste and hazardous waste in safe and reliable manner. So medical waste is pyrolyzed into CO, that is carbon monoxide, and hydrogen and hydrocarbons when it comes in contact with the plasma arc. But the difference is that these gases are burned and produced at high temperature of around 1200 degrees centigrade, just like incineration. But here the difference is that these hot gases are quenched rapidly from 500 degrees centigrade to 70 degrees centigrade, which allows which avoids the recombination of the reaction of gases molecule, and thus it inhibits the formation of dioxins and furans, which are potentially toxic. So this has an advantage of low emission rate. Waste residue is inert and sterile comparatively, thus it was environmental friendly, and there are reduction in volume comparatively more, that is 95%, to a mass reduction of 80 to 90%. Then autoclaving we all know is a permanent treatment option for biomedical waste, where it works on the principle of steam under pressure. which decontaminates the waste. So there can be either uh, gravity flow autoclave or vacuum type of autoclave with different cycle condition, where for vacuum autoclave the temperature is 121 degree centigrade with 15 pounds per square inch of pressure for 45 minutes, where this duration is more for gravitational force or flow autoclave. Again, the hazardous material and chemicals cannot be autoclaved as they release toxic emissions. At the same time, heat resistance container, because the steam cannot penetrate here, beddings and other bulky waste cannot be disinfected using autoclave. Then another technique is microwaving, where the radiation produced by the microwave breaks apart molecular chemical bond and disinfect the infectious waste. Here the advantage of using microwave is that here it produces minimum in emission, so no gases are produced. But again, volatile, semi-volatile, organic compounds, mercury, radiological waste should not be microwaved. Then to overcome the problem of autoclaving, this is again a recently introduced technique called hydroclaving. So hydroclaving is actually an advanced version of autoclaving, you can say, where it has incorporated powerful rotator mixer which breaks the biomedical waste into small pieces. At the same time, steam is filled in the double wall jacket of the vessel, which heats the vessel interior. The liquid in the vessels is turned into steam after a cycle of 20 minutes of operation, and this reduces the waste by volume and size and facilitate easy disposal. So this has an advantage of having higher and better degree of sterilization. Now finally, encapsulation and inertisation, let's have few words on it. The encapsulation involves filling of containers like polyethylene and metallic with waste by adding an immobilizing material like plastic foams, bituminous sands, which are again the cement, mortar or clay, and sealing these containers, so making these an inert one. Okay, so making these containers inert by adding these inert substances with biomedical waste after it is being shredded. The following filling the containers are sealed and placed into the landfill sites to prevent scavengers gaining access. So these are used for pharmaceutical and for incinerated ashes with a high metallic content. So the take home message is any waste which is generated during diagnosis, treatment or immunization or of human or animal or during the process of research is called as biomedical waste. The biomedical waste should be treated very cautiously. The principle of biomedical waste management includes 3 R's, that is reduce, recycle as well as reuse. And the pillar of biomedical waste management is segregation of waste at the source. With this, I finish my lecture. Thank you for your attention.